This will be our second lecture on advanced level problems on work and energy. As we have seen before, the problems may involve concepts from other chapters of mechanics as well. And for the convenience of students, we shall be using 1 dot, 2 dots or 3 dots to mark the problems as level 1, level 2 or level 3. So let us go for the next problem, which is problem number 3. And this one is telling that a smooth horizontal plane supports a stationary vertical cylinder of radius r and a disc A attached to the cylinder by a horizontal string AB of length L0. I shall give you the figure in a short time. An initial velocity vector V0 is imparted to the disc at t is equal to 0. At what time will the disc strike the cylinder? Figure is this one, the smooth horizontal plane on which stands a stationary vertical cylinder, and according to the question, the radius of its circular base is equal to r, and a string which is named AB here is attached at one end to the bottom of the cylinder and the other end is carrying a disc. I am showing the disc in blue color and the string in red color for avoiding confusion in future. This is the left side point is B in contact with the cylinder's bottom, and the right side end, that is A, which is also the same as the disc's position. And they have given that length AB is equal to L0, and at time t is equal to 0, the disc is imparted a horizontal velocity vector V0 directed perpendicularly to the length AB of the string, which itself is parallel to the edge of this horizontal plane. So at time t is equal to 0, the disc is given the velocity V0, and the question is, at what time will it strike the cylinder? So as we visualize the problem, first of all, let me put the problem in difficulty level 3. It's conceptually rather difficult, hence level is 3. So I was telling, we can imagine the motion of this disc at the end of the string as it's given this velocity V0. It starts moving around this cylindrical body, but since a part of the string is now wrapped around the cylindrical surface, the curve followed by the disc will have an instantaneous radius that is constantly decreasing in time until the disc hits the cylinder surface. To understand it better, I shall go for an overhead or top view of the horizontal plane on which this disc's motion is confined. So let's go for this two-dimensional view of the motion of disc here. First of all, I show this circular base of the cylinder. This is the center, and if I could draw a vertical line from the center of this base, this point is the point B at which one end of the string is attached. So they have given this length is L0. This point is A, and the disc imparts the velocity V0 perpendicular to the length of the string. You can see here at the beginning, that is at time t is equal to 0, the disc starts moving in a curve of radius equal to this L0. But as time passes, a part of the string now wraps around this cylindrical surface. So the effective radius of the path keeps on decreasing. I shall draw an approximate figure to show the trajectory of this disc on the horizontal plane. You can see this dashed line. I'm showing its radius decreasing in time so that eventually it falls onto the cylindrical surface. So suppose at a given instant, sometime after the launch, the disc is somewhere here, and correspondingly the string now is positioned here, right? So look at the figure carefully. A part of the string now is wrapped around cylindrical surface, and at the point C, say, this string is leaving the surface of cylinder, so the remaining length CD is the length of the string not in contact with the cylinder, and the CD now becomes the instantaneous radius of the curve followed by the disk. Moreover, the point C at which the string leaves cylindrical surface, that point C becomes the instantaneous center of curvature of the curve in which this disk is moving. Two things important. First, center of curvature at the point C at which the string leaves cylinder surface, and instantaneous radius of the path followed is equal to the length CD, that is the length of string not in contact with cylinder. Very important things to understand here.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.